Day 524 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3494. Find the minimum amount of time to brew potions. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given two integer arrays, skill and mana, of length n and m respectively. In a laboratory, n wizards must brew n potions in order. Each potion has a mana capacity of mana of j and must pass through all of the wizards sequentially to be brewed properly. The time taken by the ith wizard on the jth potion is time ij, which is equal to skill of I times mana of j. Since the brewing process is delicate, a potion must be passed to the next wizard immediately after the current wizard completes their work. This means the timing must be synchronized so that each wizard begins working on a potion exactly when it arrives. Return the minimum amount of time required for the potions to be brewed properly. All right, y'all, so I can understand how this question is a little bit hard to understand. So let's take a look at these examples to make sure that we are doing this problem correctly. So in example 1, we have our input skill equals an array of integers 1, 5, 2, and 4, and mana also equals an array of integers 5, 1, 4, and 2. The output is 1, 10. So let's look at this explanation so we can see how they got this output from this input. Boom. So let me go ahead and copy and paste this for y'all so I can show y'all or give y'all a better visual representation of what's going on. So let me just clean this up for y'all real quick. Boom. Okay. So for this first row, it's pretty simple. We start at time 0. Boom. Hold on. Let me do this. We start at time 0. Boom. Then we do 5 times 1. That's going to give us 5. Plus the 0. Well, let me come over here. Show how much time has passed. So this will be the minutes passed up here, just so y'all can see. Boom. So once again, we're starting at time 0. Boom. Then we do 5 times 1. 5. So 0. 5 times 1 is 5. So 0 plus 5 is equal to 5. Boom. And we could put the 5 right here. Boom. Then we do 5 times 25. 25 plus the 5 minutes that already passed is going to give us 30. So 5 plus 25 equals 30. So we could go ahead and put the 30 right here. Boom. Then we do 5 times 2. 5 times 2 is 10. Plus the 30 minutes that already passed is going to equal 40 minutes. So we could put the 40 right here. Boom. Then we do 5 times 4. 5 times 4 is 20. Plus the 40 minutes that already passed is going to be equal to 60. So we could put the 60 right here. Boom. So now we have our first row. That's how we got our first row. This is our first row right here. Boom. So now let's take a look at this second potion, or potion number 1, because as you can see, it starts at 52. And I'm sure a lot of people are wondering, where did this 52 come from? So let's figure that out. So first thing, let's just see how much time it will take to complete this potion if this was the only potion. So let's just imagine this is the only potion, and let's go through, see how much time it would take to complete this potion. So we start at 0, but this time we're looking at 1 because we're looking at potion number 1. So we're starting here at 1. So 1 times 1, or hold on, got to get the minutes passed as well. Boom. So start at 0. Boom. So 1 times 1 is 1. Plus 1 is going to equal 1. So we could just put the 1 right here. Boom. Then 1 times 5 is 5. Plus this 1 minute that already passed. So 1 plus 5 is equal to 6. So we could put the 6 right here. Boom. Then we do 1 times 2. 1 times 2 is 2. Plus the 6 minutes that already passed is equal to 8. So we could put the 8 right here. Then we do 1 times 4 is equal to 4. Plus the 8 minutes that already passed is equal to 12. So we could put the 12 right here. Boom. So we know this is how much time it would take if that was the only potion. But it's not the only potion. So let me copy and paste this down here just so y'all can see what the first potion really looks like. Because remember, this would be the first potion, even though it's potion 0. This is potion 0 and this is potion 1. Boom. We can't start potion 1 till a wizard can't start a potion and potion 1 until they have finished potion 2. I mean potion 0. Excuse me. They can't start a potion in potion 1 until they finish potion 0. So let's go through it. So it will start. Let's say we start at 0. Boom. This starts at 5, so we could just put a 5 right here. Boom. Then this starts at 30. This would take 1 minute, so we could just do 30 minus 1. That will give us 29. Boom. Then right here, this starts at 40, so we could do this goes with this. So oh, excuse me, we're at 30. Yeah, 30, boom, 29. So now we're at 40. So it'd be 40 minus 6. That's going to give us 34. So we can just put 34 right here. Boom. And then finally, 8 minus this 60 right here. So first we did 1, this 1 minus this 30. That's where this 29 came from. This 5 just came, or let's just say we did this 0 minus 5. Or excuse me, we did 5 minus this 0. That's where this 5 came from. Then we did 30 minus this 1. That's where this 29 came from. Then we did 40 minus 6. That's where this 34 came from. And now we're doing this 8 minus 60. And that's going to give us this 52 right here. Boom. So this 52 at the end is actually when we would start. So this would be the minimum start time. This 52 is our minimum start time. So we could just bring the 52 right here. Then we could just add 52 to or our original time, how much it would take with if that was the only potion, which are these elements to the left of the colon, which would be if it was a dictionary, it'd be the keys. So we would just add 52 to each one of these keys. So it'd be 52 plus 1. Boom. Then we get 53. Then we do 52 plus 6. Boom. That would be 58. Boom. Then we do 52 plus 8. That would be 60. Boom. And then we do 52 plus 12. And that would be 64. And that's how we got this row. And that pattern continues for the rest of the rows. We're not going to go through all of them. I just wanted to show you how we got this first row and this second row, because once you understand those principles, you'll be able to figure out how we got the rest of the rows. Boom. And then the final output, it ends up with 110. And that's how our output is 110. I'm not going to go through example 2. It's the same principles though. I encourage you to go through it on your own time, sort of like some homework though, just so you can get a better understanding of what's going on. But that is a basic example of what the question is asking. So now that we understand how the question works, let's get into the fun part, the actual solution. Solution is not that difficult at all. Now, first thing we want to do is, so the skill and mana are two separate arrays of integers, and the goal is to compute this, the minimum time of or cost based on these inputs we're going to use dynamic programming. So we're going to get n, and n is the number of skills or the length of the skills array, by saying let n equals skill.count. Boom. Then we are going to create our dynamic programming array of size n plus 1, and it's going to store intermediate computation results for different skill combinations. Initially, all of the values will start at 0. So we're going to declare a variable called dp, set that equal to an array, open up the parentheses. It's going to be repeating colon zeros. Then we're going to say comma dot count colon n plus 1. Boom. Then we're going to come underneath that. We're going to start a for loop. We're going to say for I n 0 dot dot less than mana.count. We're going to open up the brackets. And the outer loop is going to iterate through each mana value, and each iteration simulates applying a new mana effect on all of the skills. So we're going to declare a variable, but it's not used, and it's going to store possibly left over for debugging earlier logic. So we're just going to declare a variable called isDiff, and we're going to set that equal to 0. Boom. Then we're going to start another for loop. We're going to say for j and 0 dot dot less than skill dot count. Boom. We're going to open up the brackets. And we're going to forward pass or iterate over each skill index and update the dynamic programming array to be the maximum of its current value or its previous. And then we're going to add the product of the current skill and current mana to it. And this is going to simulate accumulating time based on the skill and times mana. So we're going to say dp square bracket j plus 1. We're going to set that equal to max, open up the parentheses, dp square bracket j plus 1. Come outside of that square bracket, we'll say comma dp square bracket j. Come outside of that and the parentheses, and we are going to say plus skill square bracket j times mana square bracket I. Boom. Then we're going to come underneath this for loop, and we are going to say for j in stride, open up the parentheses, from colon n minus 1 comma 2 colon 0 comma by colon negative 1. Come outside of this, we're going to open up the bracket, and this is going to be a backward pass and goes in reverse order through the dynamic programming array. It's going to adjust the dp of j by removing the effect of skills of j times mana of I, and this might be balancing out the dynamic programming array after the forward updates and showing that overlapping computations don't overcount the contributions. So we're going to say dp square bracket j we're going to set that equal to dp square bracket j plus 1. Come outside of that square bracket, we're going to say minus skill square bracket j times mana square bracket I. And then last but not least, we just need to return the last element in the dynamic programming array that contains the final accumulated result after processing all mana values by coming right here, and we just say return dp dot last exclamation point. Boom, y'all. That's all the code it took. Let's run it. Make sure it runs correctly before we submit it. It's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see, and look at that, y'all. 90 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.